Have you ever imagined a colossal train gliding through majestic mountain ranges, soaring past towering peaks? It sounds like something out of a sci-fi movie or a surreal dream, doesn't it? But believe it or not, what once seemed impossible is now becoming a reality right in China. In this country, driving trains through mountains is no longer a far-fetched idea. So how have humans managed to conquer nature in such a spectacular way? You're probably curious about the incredible technology behind these achievements. Join us as we uncover the secrets behind the extraordinary engineering feats of Chinese engineers in this video. As you may already know, a dam is a structure built to block the flow of water, allowing us to harness it for purposes like generating electricity, controlling floods, and storing water. However, these massive constructions also pose a major challenge. They disrupt the natural flow of rivers, turning them into enormous barriers. When a dam is constructed, it essentially divides a river into two parts. Upstream, the water is held back to form a vast reservoir, while downstream, the water level drops significantly. This creates a dramatic height difference between the two sides of the dam, which can span several dozen meters or even hundreds depending on the size and purpose of the structure. When a river is blocked and split into two parts, it brings commercial activity and waterway transport to a halt. This disruption doesn't just affect the movement of goods. It also impacts the lives of people who rely on the river as their main transportation route. The dam essentially turns the river into a dead end. Throughout history, various solutions have been proposed to overcome the elevation gap caused by hydroelectric dams. One of the most well-known approaches is the use of water locks, like those seen in the Panama Canal. These locks are chambers filled with water with gates at both ends. Ships enter the lock, and the water level is either raised or lowered to match the height of the next section of the river. This allows vessels to continue their journey without being stopped by elevation changes. However, water locks are only feasible when the difference in height isn't too extreme. In the case of hydroelectric dams, the gap can reach several hundred meters. Imagine having to build a staircase as tall as a 30-story building. You'd need a massive number of steps. It's the same with water locks. To bridge that kind of height, you need many of them. That's not only incredibly expensive to build but also requires a vast amount of space and time for each ship to pass through all the locks. For this reason, ship lifts were invented as a smart and efficient alternative. Unlike water locks, a ship lift can handle significant elevation changes in a single operation. Massive vessels weighing thousands of tons, instead of waiting for hours to pass through multiple locks, can now be lifted or lowered quickly, saving both time and operational costs. One of the most remarkable ship lifts is located at the Gupitan Hydropower Station, a concrete arch dam on the Wu River, a tributary of the Yangtze River in Guizhou Province, southwestern China. The dam stands at a height of 232.5 meters, and the ship lift offers a total elevation lift of 199 meters, the equivalent of a 66-story building. With the ability to handle such a massive vertical difference, the Gupitan ship lift has become one of the largest and most efficient ship lifts in the world. Ships are lifted across 3 vertical stages, moving directly from the downstream to the upstream section of the Wu River. But how exactly does this ship lift work? First, the vessel enters a massive ship chamber measuring 40 meters long and 12 meters wide. This chamber is filled with water, creating a mobile water flow that allows the vessel to be lifted or lowered. The system relies on 256 steel cables and operates vertically using a rack and pinion mechanism, with each stage taking about 30 minutes. The ship travels through all 3 levels of the lift, completing the entire process in approximately 2.5 hours. Cutting down the journey by up to 4 days compared to winding mountain routes. What makes this ship lift particularly unique is its advanced safety system, which includes a world-first combination of gear wheels, racks, and lead screws. It's engineered to withstand earthquakes up to magnitude 8, as well as strong winds and turbulent waters. The lifting system maintains a precision within just 10 millimeters, ensuring that ships weighing thousands of tons can traverse the elevation difference smoothly. This project has fully restored navigation along the Wu River, opening up a golden waterway that links Guizhou Province with the Yangtze River. It has also boosted the region's annual cargo transport capacity to 5 million tons, fueling the development of Guizhou's Central Economic Zone. As you watch a ship travel along the canal and approach the first lift, it enters the towering structure. Inside, a suspended lifting cable hangs in place, flanked on both sides by rows of drums and gear mechanisms. To many observers, such a lift might seem both unusual and sluggish. However, its designers claim that the system can raise or lower a 500-ton vessel in just about 10 minutes. The massive lifting mechanism has a maximum load capacity of 18,800 tons. While the process of fully lifting a ship might seem time-consuming, hardly anyone minds. After all, each vessel is elevated an astonishing 72 meters, and that height can vary depending on the downstream water level, with a maximum lifting height of up to 200 meters. Some have even described the Gupatan Dam ship lift as an astonishing feat of engineering. Still, not everyone agrees on whether all the praise is fully deserved. After all, several ship lift systems existed long before this one was built. The ship lift system at the Gupatan Dam is not just a single lift. It's actually a complex setup involving 3 coordinated lifts operating in sequence. After passing through the first lift, the vessel is then raised an additional 130 meters by the second. The operating principle behind this system is relatively straightforward. The ship enters a lifting chamber, waits for the system to activate, and is then elevated entirely by the powerful lifts at the Gupatan Dam. The entire waterway is elevated to a total height of 199 meters. The height to which the vessel is raised is nothing short of a technical marvel, leaving many in awe of the ingenuity and skill of Chinese engineers. Under normal circumstances, a river with such a dramatic elevation difference would be completely unnavigable. However, thanks to advanced engineering, China has made this possible, truly living up to its reputation as an infrastructure powerhouse. After passing through the first 2 lifts, the vessel must then be lowered in order to continue its journey through the waters behind the dam. To accomplish this, the system includes a 3rd lift at the end of the mountain passage, capable of lowering vessels by up to 47 meters depending on the actual water level. Originally, there was no river beneath the lift system. Ships had to traverse mountainous terrain. So in addition to constructing 3 massive lifts, engineers also had to build a crucial connecting route between them. In the end, the main link between the lifts and the surrounding mountains is an open-air water channel, an essential part of the system's infrastructure. In this project, integrating a waterway system with rugged mountainous terrain along with the entire ship lift system posed a major challenge during construction. However, Chinese engineers overcame these difficulties with remarkable skill, completing the 2nd mountain crossing route. The entire project came with a massive price tag of $7.8 billion. But thanks to the advanced ship lift system, vessels can now easily navigate some of the most treacherous terrain. Had traditional water locks been used instead, each ship would have faced significant challenges along the way. So what do you think of this engineering marvel? Let us know your thoughts in the comments below. Thanks for watching this video. Goodbye and see you in the next episode.